Hey, 6 lessons for life from an AI agent. By the time this video is over, I hope you'll understand a little bit more about AI, which should be useful as it's a really hot topic right now. And I hope you'll agree that the AI agent that I created can remind us of some useful lessons for life. Now, some time ago, I wanted to learn more about AI, and one of the YouTubers I grew to like was a guy called Siraj. He's quite a crazy guy and he issued coding challenges from time to time. One of them was about a grid walking agent whose actions were determined by a form of AI called Q-learning or reinforcement learning. His challenge was to use reinforcement learning in Python to help a grid walking agent navigate across a 5x5 matrix, avoiding death zones and regions of pain, to get to the goal in the far corner. Although I first started coding over 40 years ago, at the time I watched Siraj explaining these things, I hadn't done any serious coding for over 10 years. The video finished and it was quite a surprise that I'd understood it reasonably well. And as I thought more about the coding challenge he'd laid out, it seemed to me that I just might be able to do it. I found a few good methods of increasing innovation, and I decided to deploy 2 of them on this learning exercise. Smash myself into new ideas and create ridiculous constraints. So I ignored his advice to use Python and decided to create my solution with JavaScript running in the browser, with no libraries, with everything built from scratch. Game on! I completed the exercise, and this is my solution to the grid walking challenge from Siraj. It's a 5x5 grid surrounded by a barrier of death zones and with one death zone in the middle. The 2 pink squares are pain zones that will hurt our agent but not kill him. The goal is the green square in the bottom right hand corner. I'll speed him up shortly to about 20 moves per second. By now we can see that he's moved about 100 times, died 20 times and scored just 1 goal. At the beginning he wanders about and it looks pretty random. He's actually using a simple set of rules to learn about his environment and the punishment or rewards that he receives along the way. Gradually, the goals start to appear more regularly, and by the time our agent has died 50 or so times, he's learned enough to stop dying and concentrate on scoring more and more goals. I missed his deadline, but I really enjoyed the challenge, and I managed to get it working, and I knew a lot more about Q-learning when I'd finished. Sometime later, I decided to revisit my grid walking agent and see how far I could push it to learn some more. And now I need to explain the challenge a little bit more and give the briefest introduction to how Q-learning works. If you're part of a less technical audience watching this, stick with me and good luck. We have our 5x5 grid world and our agent lives in it. Our agent isn't so clever, but he does love to collect Bitcoin. He can move around, but every move costs him one of his precious coins. If he lands in the pain zone, he loses 5 Bitcoin. If he lands in the death zone, he loses 100 Bitcoin, but worse than that, he loses his life. Don't worry though, he gets transported immediately back to a random location in the grid and gets to try it all over again. The only way to replenish his beloved Bitcoin is to reach the goal. 100 Bitcoin are waiting there for him, and once he's collected them, he's magically transported to a random place in the grid. Of course, to us humans, this looks painfully simple. We can see the goal, we can see the pain zones, we can see the death zones, and only a fool would walk into them. But we possess actual general intelligence, and at the beginning of his life, our agent doesn't even contain 1 scrap of artificial specialized intelligence that he'll need to help him. If you're looking for a bloodbath, then our agent will not disappoint. But he can learn. To find out how, we need to understand a little bit more about the agent and the nature of the grid world he inhabits. Let's have a look at a smaller section. Our agent can't look outside his square to help him take a decision. He has no idea that there are pain zones or death zones. He has no idea that there is a goal with 100 Bitcoins. He has no idea that he's in a grid or even the concept of a grid. He knows that if he stays still, the possibility of more Bitcoin is 0. Each square is not just a simple square. It contains 9 helpers that our agent can use to guide his decision, avoid death, avoid pain, and reach the goal. He'll always move in the direction of the helper with the highest value. If there isn't a clear winner, he doesn't become paralyzed with indecision. He just tosses a coin and chooses one of the best ones at random. At the beginning, all the helpers are 0, so our agent tosses the coin and makes his move. Of course, if our agent wanders about randomly for long enough, he'll eventually land on the goal and collect his reward, and is pretty certain that he'll get hurt and die a bloody death quite a few times along the way. But our agent has a special trick. After he's moved, our agent can reach back into his previous square and update the number that he used to help him make that decision. He still can't see outside the square he's in now, so his ability to update is rather limited. So he reaches back and updates the helper number he just used so that it's a function of the original helper value in the previous cell, the reward received when he landed in the new cell, the costs incurred for his journey, and the best helper value in the new cell. So, to recap, as a grid walking agent with rather limited intelligence, I have no concept of a grid or a goal. I have no concept of my location in the grid that I have no concept of anyway. I'm trying to maximize my Bitcoin. I have no concept of death zones or pain zones, but if I land on one, there's a cost. If I move anywhere, there's a cost. I can only look at the helper numbers in my current cell to decide where to move. My trick is that I can update the helper numbers I used in the previous cell after I moved. I have no concept that I'm making a sequence of moves that might lead to a goal, and if all moves look the same, then I'll throw the dice or toss the coin. For the non-data scientists watching, if you've managed to stay with me up to here, then congratulations. You know more about AI than the vast majority of the population. Let's have a look now at how that simple strategy can work with our agent in a 30 by 30 grid. Our agent stumbles around, bruising his shins in the pain zones and becoming aware of his own mortality in the death zones. Gradually, the amount of distance he covers in between deaths increases. And as I'm going to increase the speed quite a bit, and we can still follow him on the screen, he scores more and more goals, and the amount of the grid that he understands well gets bigger and bigger. Now I'm going to increase the speed all the way to 11 and let our agent get about 10,000 goals under his belt. And then slow him down to see how well he's learned his task. Our agent can get to the goal pretty quickly, he doesn't die anymore, and while his efficiency isn't bad at about 81%, it's not excellent because we can just see that he doesn't go in a straight line. Surely artificial intelligence can do better than that. And now I want to introduce a trade-off, and it's a trade-off that we should all be able to relate to. As the agent, should I exploit the information that will lead me to a goal? Or should I explore the unknown to see if there's something better? We can make our agent take his first premeditated steps into the unknown by occasionally asking him to ignore the helper numbers in each cell and let Lady Luck decide his fate. He'll randomly decide which way to go. I've built a number of levels of exploration into our agent's model, varying from gung-ho, which sort of means over-enthusiastic verging on the stupid, through to fur-lined rut, which means he's stuck in a rut, but it's very comfortable and he likes it. So what should we choose? Well, if it's worth doing, then it must be worth doing to excess, right? Let's pick gung-ho, and at this level, he'll take a random move at about 50% of the time. I predict that he's going to die quite a lot. Now I'll pump up the speed and let him get another 5,000 goals under his belt. And if I bring the speed down now again to about 20 per second, he's still lurching around like he's had one too many vodkas at the bar. But if I tell him to stop exploring and start exploiting what he knows, we can see that he now does a pretty amazing job of not getting killed, not getting injured, and finding his goal. So in a rational, predictable world, our agent's at the very top of his game. But, I seem to hear you ask, is our world actually rational? What happens if he's suddenly blocked from achieving his goal? Let me slow him right down. and put a death zone between him and the goal. Maybe you think I've been unreasonable or irrational to put that blocker in the way. But sometimes life is like that, and our agent will just have to deal with it. Let's see what happens as we speed him up to as fast as he can go while still rendering the journey. He searches and searches for a route through, but of course there isn't one. And if I now remove the unreasonable, irrational death zone, our agent's in his very own hell. There's an open route to the goal, but he can't find it. He's using an exploitation strategy, but his exploitation data is out of date and no use to him. So what can he do? Well, he could start exploring again. I predict that he's going to die some more. With the speed set to the fastest it can go and still render, we can see that pretty quickly our agent reaches his first goal and sets about relearning the optimum routes. If I pump up the speed to the max again and let him get another 5,000 goals on board, then start him exploiting before slowing him back down again, we can see that our agent has fully recovered from the trauma of an irrational obstacle and is collecting Bitcoin again while the sun shines. So while I leave him to enjoy his moment of glory, I'd like to take a couple of minutes to recap on the things that we covered. AI is hot right now, and I think it's a good thing if everyone knows a little bit more about it. Reinforcement learning is a type of AI or machine learning that helped our agent maximize his Bitcoin collection. Our agent hasn't any concept of a goal, a pain zone, or a death zone. He has no concept of a grid or his location within it. Our agent follows some really simple rules, and when he does, he can achieve his goal consistently and quickly. I talked about the trade-off between exploitation and exploration, and how they can be used to good effect to allow our agent to achieve more. And I showed what happened when an irrational and unreasonable barrier stopped our agent from achieving his goal, and how even when it's removed, his pain didn't stop. But I hope to achieve more in this talk than a high-level understanding of one field of AI. I wanted to draw some lessons for life from our AI agent, so let me try. I have 6. Staying still won't earn us any Bitcoin. If we want rewards, we must act. To maximize our reward, we must take risks, and it will hurt. This is how we learn. Simple principles applied consistently can achieve incredible results. Choose the best route forward based on what we know, do lessons learned and use them to inform our decisions next time. And if it's hard to tell which route is best, toss the coin. Even if the world is rational, predictable and constant, an exploitation-only policy is always suboptimal. If irrational forces block you, don't give up. Even when it hurts, Bitcoin awaits the curious, the brave, and the committed. And if any of us think that we have the potential to be an irrational blocking force in someone's life, we should think really hard about the impact of our actions or inactions. When we stand in the way of agents who, for whatever reason, don't have the strength or energy to keep on trying, it can kill our progress dead. And the effects can outlast our brief moment of managerial madness. So I hope you found our AI agent's lessons for life interesting and perhaps a bit useful too. So whatever your own goals are, Bitcoin, security, belonging, happiness, love, or something else, if you keep moving, keep exploring and keep learning, I hope it will help you to have an amazing life.